Hello everyone, I am Shobon. I am covering semiconductor, conductor or insulator. I am covering this topic about. Let's to talk about insulator. A conductor, as its name implies, a substance that conducts electricity in order and conduct electricity. Electrons need the more around becomes protons and neutrons are bound the atomic nuclear. The electrons in the outermost shell of an outermost are called valence. Now these valence electrons in a series of energy level from an energy bound called a valence band. From the valence bond, electron can jump into empty band of electrons, called a conductor. Basis in a conductor, there is a no gap between insulator, a substance that does not currently insulator energy. Large gap is between valence band and conduction band. We can see conduction band and valence band are major gap. So next topic is semiconductor. Covering this topic, a semiconductor is a substance that has properties between insulator and substance. Semiconductor conduction band and valence band is a some small gap used for energy. A semiconductor electrons are moving valence band to conduction band. Silicon. What is silicon semiconductor? Example: Silicon Valley, California. Silicon has a 4 valence electrons, and the silicon atom has 4 valence band. So each silicon atom can find 2 4 others. This was all of valence electrons are used with other. They cannot move other around. Now this make a pure silicon crystal insulator, rather a conductor to increase conductivity of silicon. What is doping? Doping is called depending impurity introduced to silicon. It can be classified as N-type semiconductor and P-type semiconductor. And atom has 5 valence electrons, such as phosphorus. 4 valence electron can with 4 adjacent silicon atom, and the 5th electron the nothing bind, so it's free to move around, creates extra charge level. Now electron can easily jump to conduction on band when the energy is provided by an amplified the voltage. This is called N-type semiconductor. N-type semiconductor refers to the negative charge of the extra electron. So if an impurity has their valence electrons, such as bond 3 adjacent silicon atom, and they forms a hole, the 4 silicon nothing to the bond bound to the absence of an electrons create a positive charge. This positive charge can more from atmosphere to atom as electron leave from position. Semiconductor refers to positive charge due to the missing electrons. So where we do use semiconductor, there are many circuit use of semiconductor for a such as a temperature source. Many PN junction diode. A PN junction diode is one of the simplest semiconductor device around, and which has the characteristics of passing current is only direction only. However, unlike a resistor, a diode does not behave linearly with respect to the applied voltage, as the diode has an exponential current voltage relationship, and therefore we cannot describe its operation by simply using an equation such as P-type semiconductor and N-type semiconductor. We can see a PN junction diode semiconductor are closely circuit. N-type and P-type semiconductor materials are electrically neutral for free electrons and holes and cross the junction. However, when the free electrons and holes have crossed the junction, the N-type and P-type semiconductor become charged atom. If the atom has unequal number of electrons and protons, the atom is said to be charged. The charged atom may be positive or negative. The atom which has more number of number of proton, then the electrons is said to be positively charged. Basic semiconductor. Conductor, semiconductor or conductor. Semiconductor are mainly silicon and germanium, commonly base. Positive and negative barrier voltage at the p-n junction. In positive ion, total number of electrons orbiting the nucleus of an atom is less compared to the total number of protons present in the nucleus of an atom. Hence, it is positively charged. On the other hand, in negative ion, the total number of electrons orbiting the nucleus of an atom is more compared to the total number of protons. Thus, a net positive charge is built at the n side of the p-n junction due to the positive ions at the n side. Similarly, a net negative charge is built at the p side of the p-n junction due to the negative ions. Silicon and aluminum closely holes are included, and holes are lighting passing silicon to aluminum moving the net negative charge at the p side of the prevents the further flow of free electrons crossing from n side to p side, because the negative charge present at the p side of p-n junction repels the free electrons. Similarly, the net positive charge n side of the p-n junction prevents the further flow of holes crossing from p side to n side. Hence, positive charge present at n side, negative charge present p side p-n junction acts as barrier between p-type n-type semiconductor. When the diode is forward biased and the applied voltage is increased from zero, hardly any current flows, though the diode is beginning, because the external voltage is beginning oppose the internal barrier voltage. This is holes are lightly used. Holes is closely for electrons, aluminum electrons. This is a aluminum and silicons or holes are used for these holes, and but n-type semiconductor holes are moving silicon and photon side movely past use. A semiconductor doped with a donor, a free electron now present, and donor impurities donate negatively charged electron to the lattice. So a semiconductor that has been doped with a donor is called n-type semiconductor. N-type stands for negatively free electrons or outnumber holes in an n-type material, so the electrons are the majority carries and holes are the majority carries. In aluminum and silicon middle diffuse holes and lightly used. Formation of the p-n junction. Silicon and silicon is the positive charge and aluminum is the negative charge. Aluminum negatively used, and photon is the charge movely very slow, but photon is positive charge accepted. This formation of the p-n junction is two divided. This is the two divided line. This two divided line used silicon aluminum, silicon photon. Silicon used negative and photon used positive. Or p-type semiconductor, aluminum is negative used and silicon used, and this divided is emitter is used. So this line n-type semiconductor movely p-type semiconductor. This p-type semiconductor are no moving holes n-type semiconductor. Formation of the p-n junction divided emitter line is use voltage line. This is potential difference. Potential difference is good and potential barrier used for conductor. Potential barrier are p-n junction semiconductor are important vital role play. This p-n junction voltage play is rarely used. Formation of the PN junction. PN junction is the mostly used holes are PN junction diode. PN junction diode in forwarding bias and non-linear. This is not a straight line. That non-linear characteristics illustration that during that operation and the N junction the resistance is not constant. The slope of the PN junction diode in forwarding bias shows the resistance is very low. When a forward bias is applied to the diode, when it causes a low impedance path and permit to conduct a large amount of current, which is known as infinite current. This current starts to flow above the knee point with a small amount of external potential. The potential difference across the PN junction is maintained constant by the depletion layer action. The max amount current to the conductance is kept incomplete by the load resistance, because when the PN junction diode conducts more current than the normal specification of